Hello everyone. Welcome back to this lecture series on engineering mechanics. This is lecture number 30 and we are going to discuss on the applications of rectilinear motions comes under variable acceleration. So in the previous lecture, we have been discussing about the constant acceleration wherein we used the three relationship v is equal to u plus at, s is equal to ut plus half at square and v square is equal to u square plus 2as. So coming on to this variable acceleration, we will not be using that three equations directly. Rather, we will be going on with either differentiation or integration wherein any of that dynamic condition has been given in terms of some other condition. Either velocity can be given in terms of time, or displacement can be given in terms of time, or the velocity can be given in terms of displacement. Likewise, the relationship can be given over which we need to use either the differentiation or integration in order to solve for the required dynamic components. So we'll move on with the numerical. The first one has been given with an acceleration of a particle is defined by the relation a is equal to minus 0.8 v. Here the acceleration relationship has been given in terms of velocity, where a is expressed in meter per second square and v in meter per second. Knowing that at t is equal to 0, the velocity is 1 meter per second. That is nothing like the initial velocity is given at t is equal to 0. Right. So the initial velocity is 1 meter per second. Next, we need to determine the distance the particle will travel before it's coming to the rest condition. That's what is the first question. And the time required for the particle velocity to be reduced by 50% of its initial value. So here the initial velocity is given as 1 meter per second. Therefore, we are supposed to calculate the time required for the particle when its velocity is 0.5 meter per second. That's what is the equation. Okay. So let us go with this one. First, the equation. We need to have the equation. Acceleration is given in terms of velocity. So in that case, either we can use a is equal to dv by dt, or otherwise we can even use a is equal to v into dv by dx. So any of these two can be used for this one. Let us start with the first question. Here we need to find that the distance the particle will travel before coming to rest. Okay, so in this case s is available before coming to rest, v is available for which a to be used. Therefore we need to have the acceleration equation which should have s and v. Okay, therefore we can have a is equal to v into dv by dx or ds, okay, which is equal to 0.8 v. Right. So I can bring the this v can be getting cancelled on both the sides. So v and v will be getting cancelled. Therefore dv will be equal to minus 0.8 dx. Now integrating this one on both the sides, wherein the velocity will be equated from initial to final velocity. Here the initial velocity is given as 1 meter per second. That's why 1 to v, and the distance is 0 to ex. So integrating this one will be getting left side as v and the right side as minus 0.8 ex. Okay. Sorry, v minus 1 because the lower limit is 1. So v minus 1 will be equal to minus 0.8 ex. Okay. So here they are asking at the velocity, that is before coming to rest, which means that the final velocity is 0. Okay. So for v is equal to 0, substituting in this one, we will be getting minus 1 will be equal to minus 0.8 x. So solving, x can be calculated as 1.25 meter. That is the distance traveled by the particle before it is coming to rest. Okay. So the first question is over. Second question is we need to find the time required for the particle's velocity to be reduced by 50% of its initial value. So here we need to find the velocity for some time interval. So therefore this acceleration can be written as a is equal to dv by dt. Okay, so a is equal to dv by dt, which will be equal to minus 0.8 v, and we can bring the v on one side and t on the other side. So we'll have dv by v will be equal to minus 0.8 dt. Integrating on both the sides with the limits 1 to v and 0 to t, we will have ln v by 1. Substituting the limits, we will have ln v minus ln 1 will be there, or otherwise ln v by 1, which will be equal to minus 0.8 t. if the ln is taken to the other side means we'll have e power minus 0.8t, or otherwise you can keep it as such ln into 0.5 divided by 1, which will be equal to minus 0.8t. We are supposed to calculate the time only. Okay, ln is nothing like the natural logarithm, right? So they are asking the time for the particle's velocity to be reduced by 50% of its initial value. That's why at v is equal to 0.5 meter per second we need to calculate. That's what has been taken. Okay, so substituting the value of v is equal to 0.5, we'll be getting the time as 0.867 seconds. Now moving on with the second example, here a projectile is entering into a resisting medium at x is equal to 0. This is the initial point. With the initial velocity of 300 meter per second. At this point, the velocity is being 300 meter per second. Since it is going to enter into this medium, so velocity will be gradually reducing and travels 10 centimeter before coming to rest. It may travel up to some distance. That distance has been 10 centimeter, before which the velocity at this point velocity becomes 0. Okay, so assuming that the velocity of the projectile is defined by the relation v is equal to u minus kx, determine the initial acceleration of the projectile as well as the time required for the projectile to penetrate 9.91 centimeter into the resisting medium. Okay, now here you can see the relationship which has been given as v is equal to u minus kx. Here u is given as 300 meter per second. Whereas now one more thing is that k is a constant which is available that we are supposed to calculate, for which the boundary conditions has to be taken. Okay, so what is the boundary condition here is at the 0.1 meter, that is here it's been given before coming to rest, that is it travels 10 centimeter before it's coming to rest. That is at a distance of 10 centimeter, v is equal to 0. That is at x is equal to 0.1 meter, v is equal to 0. So substituting this one, we will get a 0 will be equal to initial velocity is 300 minus k into, writing in terms of meter, 0.1. We'll get k is equal to 3000. Now substituting this equation, we will get v is equal to 300 minus 3000 x. Okay, so this is what the final relationship of the velocity in terms of displacement has been given. Right, now we are supposed to calculate the initial acceleration. Okay, initial acceleration, that is at a time is equal to 0. Therefore a can be written as dv by dt. Okay, a can be written as dv by dt, in which v is being given. So a is equal to dv by dt, which is equal to d by dt of 300 minus 3000 x. So d by dt of 300 will becomes 0, whereas d by dt of minus 3000 x will become 3000 can be taken outside, so minus 3000 into dx by dt. That dx by dt is nothing like the velocity. Therefore this can be written as minus 3000 v, in which v is 300 minus 3000 x. So substituting that one, we are having minus 3000 into 300 minus 3000 x. Okay, so here we are supposed to find the initial acceleration of the projectile, that is at x is equal to 0. Okay, at x is equal to 0. So at x is equal to 0, we can able to find out the acceleration, that is a is equal to minus 3000 into 300 minus this will become 0. Therefore we will get minus 9 into 10 power 5 meter per second square. We are getting a negative value, which means deceleration, right? It is reducing once it is entering into the medium. So that is what is the first question, the initial acceleration of the projectile. Second one is the time required for the projectile to penetrate 9.91 centimeter into the resisting medium. That is, we need to find the time over a distance. So v can be written as dx by dt. Okay, v is equal to dx by dt, which is given as 300 minus 3000 x. Okay, so now taking x components on one side and t components on the other side, we'll have an integrating further. We are integrating dx by 300 minus 3000 x equal to dt. On integrating, will be having the left side component will be ln 300 minus 3000 x, and already we have one more variable is available, so that you'll be getting minus 1 by 3000 into ln. Okay, minus 1 by 3000 into ln of 300 minus 3000 x with the limit 0 to x. Okay, with the limits, I didn't mention that one, with the limits 0 to x minus 3000. Okay, I think the limits has been substituted. That's why it's been given. Okay, so this will become, I'll write it here, minus 1 by 3000 into ln 300 minus 3000x, and the limits are 0 to x, which will be equal to t. Right. So substituting the limits, we will be getting ln 300 minus 3000x minus this one 300 minus 0. Okay. So that is what minus 300 alone will be there. Okay. So this can be written, and we are supposed to calculate that x is equal to 9.91 centimeter. That's what has been written in terms of meter, 0.0991 meter. And we can take this one ln 300 again. Since it is negative, I can write this one more step. That is, if you are taking this one in the sense, we will be getting minus 1 by 3000 into ln of 300 minus 3000x divided by 300 will be there. That is, log a minus log b can be written as log of a by b. This is equal to t. So taking this negative sign within that one, so we'll be getting 1 by 3000 into ln of 300 divided by 300 minus 3000x, which will be equal to t. That is what has been taken here. Okay. So that 1 by 3000 is that. Okay. That has been taken on the other side. So that will become 3000 t. Okay. And we need to calculate t only. So that will be substituting the value of x. I think minus 1 by 3000 has been missing in this one. So substituting that one also, we'll get the t value as 1.57 into 10 power minus 3 seconds. That is 1.57 milliseconds. Okay. Moving on with the next example. A ball is dropped from a boat so that it strikes the surface of a lake with a speed of 16.5 meter per second. While in the water, the ball experiences an acceleration of a is equal to 10 minus 0.8 v, where a and v are expressed in meter per second square and meter per second respectively. Knowing the ball takes 3 seconds to reach the bottom of the lake, determine the depth of the lake as well as the speed of the ball when it hits the bottom of the lake. Okay, so first of all, you can see the relationship is given for acceleration in terms of velocity. Right? So a ball is dropped from the boat. Okay, so that it strikes the surface of the lake with a speed of 16.5 meter per second. So while in water, the ball experiences an acceleration. It's not moving along with the gravity because it is inside the water. Okay. Knowing the ball takes 3 seconds to reach the bottom of the lake, we are supposed to calculate the depth as well as the speed when it hits the bottom of the lake. Okay. So we are writing that one. Again, we are supposed to calculate the velocity, right, at some time intervals. So we are taking a is equal to dv by dt. That is equal to 10 minus 0.8 v. Okay. So bringing v on one side and dt t on the other side, will have, and integrating this one, dv by 10 minus 0.8 v will be equal to dt. And limits are u to v and 0 to t. So this one on integrating, we will have minus 1 by 0.8 v, sorry, minus 1 by 0.8 into ln 10 minus 0.8 v. Okay, that's what has been written here. 1 by minus 0.8 into ln of 10 minus 0.8 v with the limits of u to v, which will be equal to t. Okay, so substituting the limits, we will have ln 10 minus 0.8 v divided by 10 minus 0.8 u, which will be equal to, taking this minus 0.8 on the other side, minus 0.8 t. Okay. Now I can take this ln on the other side so that this will become e power minus 0.8 t. Then I'm taking this 10 minus 0.8 u or to the right side. Therefore, we'll have 10 minus 0.8 v will be equal to 10 minus 0.8 u into e power minus 0.8 t. Okay, they gave the initial velocity is 16.5 meter per second. That is the initial velocity of the lake portion. Okay, when it strikes the surface of the lake, that's what the initial velocity within the water body. Okay, so u is known. Substituting the value of u, we will have again repeating that one. Okay, so I'm bringing this 10 on one side so that I can have only V on the one side. So I can take this one and I can take this one, so that you need to have a positive value. So 0.8 V will be equal to 0.8 V will be equal to 10 minus 0.8 U into e power minus 0.8 T. That's what has been written here. Okay, and we know U is equal to this one 16.5. And one more thing is that before that I can bring this 0.8 to the right side. So V equal to 10 divided by 0.8 will become 12.5, and again here also 10 divided by 0.8 will become 12.5, and this will become 1. Okay, so that's what has been written. V is equal to 12.5 minus of 12.5 minus U into e power minus 0.8 T. And again substituting the value of U is equal to what is that one 16.5. So we will be getting 12.5 minus 16.5 will get minus 4, and minus of minus will become plus 4. So 12.5 plus 4 e power minus 0.8 T. So that is what is the velocity equation. And if you want to find out displacement in the sense, we can differentiate this velocity in terms of time. So V is equal to dx by dt. Again, bringing the t on one side and x on other side, we will have dx will be equal to 12.5 plus 4 e power minus 0.8 t into dt, and integrating with the limit 0 to x and 0 to t, left side will become x, whereas the right side will become 12.5 t plus 4 e power minus 0.8 t, and again the differentiation plays a role. Okay, so that you'll be getting 12.5 t minus will be that. Okay, so minus because 1 divided by 0.8 will be there. Okay, 4 divided by 0.8 will become 5 e power minus 0.8 t. Substituting the limit 0 to t, we will have the first equation as 12.5 plus 5 e power minus 5 e power minus 0.8 t alone will be there. Substituting the limit 0, this component alone will become 0, whereas this one will become available. Okay, so solving this one, we will be getting this equation. Okay, so the question is at x is equal to 3 seconds, at x is equal to 3 seconds, at t is equal to 3 seconds, what is the distance traveled is to be calculated. Okay, so substituting the value of t is equal to 3 seconds, we are getting the depth of the lake is 42.05 meter. That is the first question. Second question is, what is the velocity at which the object will hit the bottom of the lake? So V is equal to 12.5 plus 4 e power minus 0.8 t. Okay, so substituting the value of t is equal to 3 seconds, we will get the velocity as 12.86 meter per second. Okay, so that's what has been asked in this particular problem. Okay, so with this, we are completing this lecture. In the next lecture, we will move on with the same rectilinear motion, but here the object will not be moving in a horizontal path, rather it will be moving in a vertical path. That is, motion under gravity condition will be taken into account. Thank you.